Lagrangian of the particle of mass m moving in one dimension is given and the coordinate of the particle x of t is asked. Lagrangian of the particle is given as L equal to half mx dot square minus bx. The equation of motion is d by dt of dou L by dou x dot minus dou L by dou x equal to this 0. This is the equation of motion. So finding dou L by dou x dot and dou L by dou x, we will find the equation of motion for this Lagrangian. So d by dt of dou L by dou x dot is mx dot and dou L by dou x is here minus b, minus of minus plus b equal to 0. So differentiating mx dot with respect to time, we get mx double dot plus b equal to 0. This is the equation of motion. So what we want is the x of t. So we have to solve this equation of motion. So to solve the equation of motion, x double dot, that is equal to d square x by dt square equal to minus b by m, that is b taking right hand side and m to the denominator. So integrating, we get dx by dt equal to minus b by m t plus c1 is the integration constant. So again integration, we get x of t equal to minus b t square by 2m plus c1t plus c2. Again second integration constant. So this is the x of t for this given Lagrangian. If you know c1 and c2, we can find it from the initial condition. If given, we can find x of